Hello guys, welcome to the bonus 3 in which I'm gonna complete the deduction of the quadratic formula. Remember that we left, we got this far. We had, remember the relabeling, b over a equals k, c over a equals m. I made that for simplicity purposes. And then we completed the perfect square trinomial and we arrived at the solution, this one here. You can go check the first video that we saw and make sure about that. X equals all of this, which is in terms of K and M. And I told you if we go back to our original constants, which are B and A and C and A, then I can again substitute again K for what it is and M for what it is, and this is gonna be our solution. Okay, and basically at this point, like I said before, we are completely done. But the only uh, uh, let's say the only possible source of confusion is that this doesn't look like the general quadratic formula. Okay, this is what you understand by the quadratic formula. Okay, this is what we all understand by the quadratic formula, and they don't look the same, this and this. So I'm gonna tell you now how to go from this to this, or basically from this to this. In the end, this is the same as this, which is the same as this. Okay, so whether I go from here to here or from here to here, it's basically the same thing. I'm gonna start with this. Okay, I think it's a better way to do it. It's faster because of the same thing I told you before. Because when I work with this expression, I'm not using fractions. Okay, so I'm using less constants, and that's gonna be much simpler. Okay, so let's start. Uh, Before we go into the whole process, which is a little long, I need to tell you about this property. I don't know if you remember that the square root of the product of two numbers is equal to the square root of the first number times the square root of the second number. This is a property that can be proven very easily by using this other property. And this one we have proven, okay? You must remember this fact, this law that we proved the last semester, and using this we can prove that thing. So I'm gonna skip the proof because I don't want this video to be very long. Just keep in mind this fact. This is true according to this law. Okay, and so now we can begin. I'm gonna erase the whole thing again for convenience purposes, and I'm gonna start just with this. We have the following: x equals minus k over 2 plus minus the square root of k over 2 squared minus m. And we have the following relabelings. Remember, we have that b over a is equal to k and c over a is equal to m. Okay, perfect. So let's continue with the developing of the deduction. What I'm going to do first is the following. I'm going to raise this fraction to the square. So we get this, right? Then that implies that now I can do the following. I'm going to transform this m into the following, into 4m over 4. It's the same, right? 4m over 4 is equal to m, so I can do it just fine. And the reason I transform this m into this form is so that I can do the following. Look, since these two fractions now have equal denominators, I can add them or subtract them like so. You see, that is the reason why I did that. So I can put them like so. And why did I want to do this? Because of the following step. The square root of a fraction is equal to the square root of both the numerator over the square root of the denominator. It's similar to this. If you This is the one I told you a moment ago, and this also works. Okay. Okay. And why did I want to separate this square root of a fraction into these two square roots? Well, because I know that 4 does have a square root, an integer square root. So that's why I wanted to do that. I'm going to continue here. We have x equals minus k over 2 plus minus the square root of k squared minus 4m over 2. You see? And why did I want to transform this into just a number 2? So that this fraction and this fraction have equal denominators, and I can do now the following. Minus k plus minus the square root of all of this over 2. That's why I wanted to do that. You see? Okay, perfect. We're we're getting closer to the solution. Okay, now what? This still doesn't look like the quadratic formula. Okay, now what I want you to do is the following. I want you to multiply this fraction by a in both sides of the fraction. Okay, so basically we're getting an equivalent fraction. You see, when you multiply a fraction in both sides by the same number, you get an equivalent fraction. I'm gonna do that. I'm gonna multiply this by a and this by a. So here we go. Remember that sometimes the steps that a mathematician takes or makes, sometimes they seem weird or obscure, but that's not. I mean, you should not be asking why are you multiplying by a in both sides. What you should be asking yourself is this valid? And if the answer is yes, then so be it. Okay, you will see why I'm doing this in a moment. Okay, so it's a times minus k. That's gonna be minus ak, and then we have a plus minus, and then a times this root. Okay, and then over 2a. So you can see already that we already have the 2a that is the denominator of the quadratic formula. You see, we already have that. Okay, now what? Okay, now we're gonna go to our relabelings, which are these two, right? And what I'm gonna do next is I'm gonna do that in blue because that's a little deviation from the from the course. We have this and this, and what I want to do is I want to multiply this equation by a in both sides. So if we do that, we get b equals ak, and this equation I'm going to multiply it in both sides by a squared. So if we do that, we get ac equals a squared m. Remember, all of these steps look weird at first sight, but as long as they are valid, I can do them, and so be it. Okay, so we have this, and we have this. Let's continue. I'm gonna continue over here, and hopefully it will fit. Okay, now, why did I do these things? What these multiplications by a and by a squared? Okay, so that I can go back to my original constants in here. Look, we have x equals minus ak. What is ak? AK is equal to B. You see? That's why I did it. So we get minus B. And then we have plus minus. Plus minus A. A times the square root of, well, I forgot a little step. I'm sorry. A little step I forgot. Before we do what I was doing, in let me first do this. Sorry about that, guys. When I rewrite this thing in this way, look. Okay, check what I just did. The only change that I did from this step to this step is reshaping this a, as the square root of a to the square. Again, is that valid? Absolutely, right? The square root of a to the square is just a. So it's valid and I can do it. Now, why did I do this? Because I want to express this multiplication of square roots, this square root times this square root, as a single square root. One more time, making use of this property. The square root of ab equals the square root of a times the square root of b. So I'm going from this to that. Okay, that's why I did that step. So let's go. X equals minus ak plus minus the square root of this number times all of this number according to this property. Make sure of this is probably the most confusing part of this thing. Okay, this will be in the end this, and I want you to make complete sure about that on your own. Remember, you can stop the video at any point. Make sure about this. All I used from going from this to this step, I used this property. That's all I did. Okay, now let's continue. Then we have that x equals minus ak plus minus a squared times k squared, which is a squared times k squared, and then minus a squared times 4m, which is 4a squared m over 2a. Then x equals minus ak plus minus the square root, and this can be written as ak, all of that to the square, minus the same over 2a. And now I believe we are done in order to deduct the whole thing. Now we use these things in blue. Okay, so let's see. X equals minus ak, and we know from doing this little thing in here in blue that ak equals b. So I'm going to substitute. AK is b, and I'm going back to my original constants. You see, plus minus the square root, plus minus the square root of ak to the square. But what is ak? AK is b. So this is going to be b to the square, you see? Minus 4 times a squared m. But what is a squared m? It's ac, you see? So I substitute like so. And as you can see, the quadratic formula is appearing. This doesn't change. And we are completely done. 2a. So we have deduced that x equals minus b plus minus the square root of b squared minus 4ac over 2a. I know it's a long process, guys. Well, relatively, right? I mean, this is still very basic mathematics, but when one is in high school or junior high, this may seem complicated. I did this in my first year of college, or the last year of high school, and it seemed like a very very long process. And but now it's just, it's very easy to understand with a lot of practice, right? With a lot of years. But at first, I understand if you think this is very very long and very complex. Okay, so we're done. Okay, it's all of these steps. It's, if you notice, it's just carrying out at every single step only a very small algebraic change takes place, okay, in every single step. I know there are too many, like, I don't know, 12 or something, but I believe that every single step is pretty understandable, pretty intelligible. And so that's how you deduce the quadratic formula in its most common form, which is this. Okay, this is the most common form. So that's it. I hope you practice this on your own. Study it. What everything I did, study it. If there are questions, ask me. And I hope that once you have studied, learn it, and do the same on your own. If you can achieve this on your own, maybe a couple of times or 3 times, that's a great exercise, guys. It's a great algebraic and mathematical exercise. Okay, if you forget about this process in the future, it's that's not to be worried about. Okay, it's not bad, but right now you should be able to do it on your own at least a couple of times. So thank you guys, and bye bye.